Okay, so on the radical part here, let's just talk about the square root here. There's two different types of square roots actually. Okay, the one that most people look at is, in a real world situation, is the principal square root. So what does that mean? Well, that just means that if you take the square root of 25, okay, that's equal to 5 because 5 times 5 is 25. Okay, so we say the principal square root is just this number here. However, if we take a negative 5 times a negative 5, we also get 25. So the square root of 25 is really plus or minus 5. Okay? It could also be a negative because a negative times a negative is a positive. But the principal square root is what you mostly are going to deal with in a real life situation. In a mathematical sense, it could be both. Okay? A lot of times in here, they're just talking about the principal square root. Okay? So, but it's important that you know that it can be a negative. All right? So if we want to have the square root of 36, oops, that's equal to 6, right? That's the principal square root. However, it's really equal to plus or minus 6 in a mathematical sense because negative times a negative is positive. So the big thing, and I noticed this kind of messed a couple people up in my Saturday last spring, is the difference between evaluate and simplify in square roots. Evaluate means we're going to use some sort of a calculator, all right? So next week I was thinking about this also because I'm not going to be here and I know who the substitute is. Using Desmos is probably going to be frowned upon. So, but I started thinking you really don't need Desmos for anything that we've done because it doesn't help you with factoring, it doesn't help you with this stuff here, except it does find square roots. So you might want to find some sort of a calculator that will allow you to do some square roots. Or what I'll do is I'll just put evaluate ones on there that are really easy. Okay, so you don't have to worry about having some sort of a calculator device. But I'll show you kind of how to do them on the calculator, all right, that I have, and then during the final when I'll be here, you can use whatever device you want. Okay, so evaluate means you're going to use some sort of calculator or calculate. So if we're going to go to the square root of 30, okay, I'm going to go find my calculator here, calculator right there, and I need square root. I also need glasses so I can see. And I don't care if you use your phone or anything like that, but so on here, the square root, I think I have to push the number first and then hit square root. That's probably how this works. Yep. It disappeared on me. 5.47. Okay, so that's how you evaluate a square root. You're going to use a calculator of some type. All right, to evaluate a square root. And depending on the calculator, you might have to put the square root first. Good calculators like TIs, I see some of you kind of have those. You push the square root and then the number because you type it in the way you say it. So So if you said the square root of 120, you would go square root 120. All right, but in this case, I have to use mine. You just have to put in the number and then square root it. And I'm just kind of rounding them to the hundreds. Okay, I don't think they actually ask you, they just say evaluate. All right, so if you went tenths, probably not a big deal. Kind of depends on the situation and the life deal. So when you see evaluate, always looking for the principal square root. Don't worry about the negative part. Let's see. They have some stuff like this. Square root of a fraction. So when you have the square root of like a fraction here, like this, you could do it a couple different ways. You can break it down into this, okay, or you can treat it as the whole 1/9. All right. Either way, you're going to get 1 over 3, okay, because the square root of 1 is 1, the square root of 9 is 3. So you can either think of it this way, or you can just think of it as the whole thing. Whatever makes it easy for you, it doesn't really matter. But you're going to get 1/3. All right. And you wouldn't have to write this, of course. You know, just think about it that way. There are some misconceptions about square roots, something like this. Okay, this is equal to the square root of 29. Which is then equal to, last time again, 5.39. Why does this get big? Okay. Although there are some that would say, well, why wouldn't this be the same as this? Which is different. Okay. So there's a difference between the square root of 4 plus 25 inside and the square root of 4 plus the square root of 25. Like that. Those two things are obviously different. Okay, so when you see something like this, add first and then take the square root. When you see something like this, square root, and then add. Is that okay? Does that make sense a little better? Okay. The other thing with square roots, come on, is this. So if we put a -9 in there, so I'm going to go 9. Where's my negative button at? There, and hit square root. It says invalid input. So the deal with the square root is you cannot take the square root of a negative number. So this is not a real number. So what does that exactly mean? Okay, you might recall from Math 60 and Math 20, I think, if you were in any of those courses, that real numbers, okay, are all the numbers in the number system. So any number that we can think of, that's called a real number. All right. So that's what they're saying here, is they're saying that this is not a, the square root of negative 9 is not a real number. There is another number system that deals with those, but we're not going to have to worry about that for a while. Okay. I think that only comes up in 95. I don't think it comes up in here, but I believe it comes up in 95. Okay. So, you can't take the square root of a negative number. All right. However, you can do this. Again, this is different because now the negative's out in front, and that's okay. So I would just say, well, that's just negative 3. And again, these are all principal square roots, okay? So they're not dealing with the true mathematic definition of a square root. Okay, these are all principal square roots. Okay, so along with square roots, in 7.1 they talk about other roots. So I'm just going to put down here other roots. And the first one is a cube root. Okay, symbolized by this. All right, and there are the other ones. There's lots of different roots. There's fourth roots and fifth roots and sixth roots. Okay, I'm just going to put an n root symbolized by this. All right, so if we want to find some cube roots using, so we're still evaluating, right? So if I want to do a cube root of 100, I should have that on here, but perhaps not. Oh, I think if I hit this and this, no. Oh, there it is. So on my little calculator thing, I have little tiny arrows, you might be able to see them, okay, which means that there's more stuff. So if I hit this, I'm going to get more options, okay. So what you would be looking for on your calculator is something that looks like this. Mine shows a radical sign here, a root sign with a y and an x. Okay, so the y is kind of small. So that way you can input what the root power is. So let's see how it works though. So let's see. I'm going to try going 100. Oops, I got to clear this out. 100. I'm going to push this and then push 3 and see if it works. Yep. So here's the order that I went. Clear. On this particular one, I had to go 100, hit that button, and then hit 3 because it was a cube root, and it tells me what it is. Okay? Now on yours, it's hard to say what it could be, the order. If you have a TI, you put the root power in first. So if you have some of your TI calculators, Texas Instrument calculators, you would go this, and it probably looks like this, that button, and then 100. Oh yeah, I was going to show that too. It works great in Desmos, actually, doesn't it? Let's go pop and see that. I'll show you how it works in that. So square roots are right there. Okay, tells you what it is. And then, did you find the cube root ones? Is that in the functions? And then they're miscellaneous?
Yes.
And it's right here, correct?
Yes.
And you just got to put in a little power thing there. Yeah, it works great. Okay. The problem's going to be, I don't know, I don't have any problem using it, but when you do your test, I'll have to just come up with something that's, when you do the evaluations, that are really simple, straightforward, so that I don't have to worry about you getting in trouble for, or me getting in trouble, or anybody getting in trouble for using it. Okay, even though they want you to use Desmos. I don't know, it's kind of strange. So that's evaluating, and you can, in a cube root, you can evaluate a negative number. So if we go negative 64, we can actually do that. So I know you didn't see it what I wrote there, but if I go cube root, not there. What the heck? It works, okay? Because negative 4 times negative 4 times negative 4 is negative 64. So you can take the cube root of a negative number, but not the square root. All right. I'm waiting. There it goes. Okay. So cube roots, yes. Square roots, no. Right. So there'll be problems on from 7.1 where you just gotta find cube roots and square roots and fourth roots and whatever, and you can use Desmos on it, and it works out pretty well, or use your calculator, whatever you want. All right. But on the test, then what I could do for evaluate is just make them straightforward. So evaluate square root of 16. All right. I'll do something like, I'll figure something out. Any questions on that part on square roots? So what I didn't do is talk about simplifying. All right. So we'll take our little break and I'll come back. We'll do 7.2, all right, which will deal with simplifying that part, so so you can see the difference between them. All right, and then we'll do some little practice problems and take our quiz, and that'll be it. So we won't be here too much longer, I don't think. All right. Okay. I'll go print out that review for you, and we'll be back in about 10 minutes or so. Okay, so we'll go ahead and get going here. So 7.2 is going to talk about simplifying and basically multiplying and dividing square roots. Okay, so this is going to look real familiar. No, go away. Okay, so these are our perfect squares, they're called. And when simplifying, you need those. Okay, we need to know what they are. Not so much the left-hand column, but definitely the right-hand column. Okay, that's kind of what we need. So square roots are a lot like fractions. So when you evaluate a fraction, you just kind of take top number, divide by bottom, you get a decimal, so forth. But in a square root, evaluating is a calculator. All right. Fractions you always reduce down to lowest terms, okay, by finding common factors. In a square root, we're going to use these things, okay, to simplify them. So when you see simplify, we're not going to use a calculator. Evaluate, we do. Simplify, we do not. So if we have the square root of 8, okay, what we want to do is find which of these numbers on the right hand side go into 8 evenly. So we want to find the largest possible number that goes into that 8 evenly. Okay, well, 4 obviously is our choice. So I'm going to write this like this. Okay, so I'm going to break it down into 4 times 2, because 4 times 2 obviously is 8. All right. So now I'm going to take the square root. So I'm going to take the square root of 4, which is 2. So that 2 is going to go on the outside. The square root of 2 I can't do anything with. It stays on the inside. So this is called simplified. All right, so we took the 8. We said, all right, which one of these numbers here in this right-hand column go into that 8 evenly? We had 4. 4 times 2 is 8. So the square root of 4 is 2. It comes on the outside. This 2 goes right there. All right, that's how you simplify. But you can only use, all right, these numbers here. Okay, those are the only ones that's supposed to be a highlight, but obviously it's not. We're only going to use those numbers. So let's try some more. So let's go with the square root of, for example, 48. All right. So now what we want to do is find the largest of these numbers that go into 48. So what number? So let's go down the chart. So what number goes into 48 evenly? What's the first one we see? Now remember, you're going down this column. So 4 goes in there. What else? Does 9 go in there? 16 go in there? 16 goes in there. Okay. Now, once you get at a certain number, it's not going to work no matter what you do. So 25 isn't going to work, and 36 is way too big. So how many times does 16 go in there? 3. Okay. So then what I'm going to do now is say, all right, now that I know I got the largest number that goes in there evenly, then I got to find the square root of that number. So what's the square root of 16? 4. So the 4 goes on the outside, and the 3 stays on the inside. All right, this 3 is going to go here. Square root of 16 is 4. It goes on the outside. That's how you simplify them. You got to find the largest number that goes into the number you're square rooting. Alright, so let's try 72. Going back to this chart, we want to find the largest number that goes into 72. I think 4 does. 9 does. Anything larger than that? 36. How many times does 36 go in there? 2, somebody said. Okay, so what's the answer that's going to be then? We got to get the square root of 36. What's that? 6. So 6 goes on the outside. stays on the inside. Okay, this 2 goes here. This 36 squared, 36 is 6. All right, that's how you simplify them. Okay, so you don't want to use your calculator to just go square root of 48. It's not going to work because we're simplifying. Oh, let's do the same thing. So let's say you went with 9, because you didn't know 36 went in there. How many times does 9 go in there? 8. Okay, so now the square root of 9 is 3 square roots of 8. But the 8 can be broken down, see? So it's just like having a fraction that's not completely reduced. That's why you want to find the largest number that goes in there. So here you'd have to break this 8 down more, and finally we would have 6 square roots of 2. All right, so that's why you always want to find the largest number that goes in there, because this requires a couple extra steps. Always find that largest number. Okay, 125. What's our number that goes into 125? This one's pretty straightforward. $25. $25 goes in there how many times? 5 times. Okay, so what's the answer going to be? 5 square root 5. Yep. This 5 goes here. Square root of 25 out on the front. All right. That's how you simplify them. Now you are going to have some that look like this. Let's see, are they nice numbers? Some of them are nice. Nope. Okay. Let's do one like this, and then we'll talk about. Okay, so we have 12x to the 4th. All right, now we have a variable inside. First, we're going to deal with the number. What's the largest perfect square? It goes into 12. We'll back up to that chart. What is it? Okay, but it's now 6. See, 6 is not in this thing here. Okay. It's got to be these numbers. 4. So 4 goes in there how many times? 3 times. Okay? So, here's what I'm going to do. First of all, I'm going to put the 3 inside. I know that stays. Square root of 4 is 2. Now I have to deal with the x to the 4th. Okay? One way to think about this is there's a little 2 right there. We just never write it because it's a square root. Okay? That 2 divides into this evenly. It goes in there twice. So what that means is that the square root of x to the 4th is just x squared. So I would put an x squared out in front, and that would be done. All right. So this 2 goes into the 4 evenly twice. It goes in there twice, so that's why I have x squared. All right. Now let's do one that's not same kind of idea, but a little bit different. Let's try 27x to the 5th. So let's try, now we have an odd power on our variable. Okay, still I got to find the largest perfect square. It goes into 27. 9, good. Goes in there how many times? 3. Okay, so I know I'm going to have a 3 here, and I know I'm going to have a 3 here, because this 3 is going to go there. Square root of 9 is 3. Now I've got this little 2 sitting out front here like this. Okay? 2 goes into 5. 2 goes into 5 how many times? Twice. With how much left over? 1. So we're going to put an x squared out in front and an x inside. Alright? 2 goes into 5 twice. 2 goes into 5 twice. Right there with 1 left over. Okay? So you kind of have to do the little division in your head. Alright? That's the easiest way to do them. A little bit tricky, but that's how that works. Okay, so let's try this one out. 36x to the 7th. First we got to break down to 36. Well, wait a second. Square root of 36 is right there. So we don't really have to break it down. What is the square root of 36? 6 is going to be on the outside. All right, now we got that 2. 2 goes into 7 how many times? Goes in there 3 times with how much left over? 1. So we're going to get an x to the 3rd here, square root, x inside. We don't have any numbers inside because the square root of 36 is 6. Okay? Square root of 36 is 6. So we don't have to break that one down. Remember, you're only using the ones, these numbers, here. Those are the ones, you know, that we're working with. I'd have those numbers written down someplace on a piece of paper or whatever you're going to use, so that when you're doing your simplifying of square roots, you're looking at them. Okay, so let's continue to simplify. Let's do something like this. Square root of 5 over 9. What the heck? There we go. Okay, square root of 5 over 16. Alright, so now we have like a little division thing, fraction just like we did before, except we're simplifying. Alright, so can we take the square root of 5? No. Can we break it down? Do any of these numbers up here go into 5 evenly? 1, 4, 9, any of those go into 5? No. So then it's done. We can't do anything with it. Alright, so I just go square root 5. Okay. What about 16? 4. So the 4 stays here, and that's it. Okay. We don't have to do anything else with it. We can't break down the 5, so we leave it. Square root of 16 is 4. We did that one. That's how those ones work. Now you could have one like this. Oops. Well, we'll make it work. Square root of okay, so we could have something like this where we have the square root of 5 over the square root of 20. I can rewrite that like this. Okay, that's legal mathematically. Then I can reduce that fraction. What's 5 over 20? What's that equal to as a reduced simplified fraction? 1 over 4. Okay. Now, what's the square root of 1? What's the square root of 4? That's how you would handle that. Okay. So it's sometimes easier to take this type of a problem, write it like this, reduce the fraction, and then square root it. Okay. I'm just looking at different ones I see that are in the book here that come up. And we haven't even multiplied yet. Any questions on simplifying? It's a little tricky. We just got to know those numbers. Okay, so let's try doing some multiplication. I think my battery, my pen's dying out here. Okay, so I'm going to try some multiplication. All right, it's pretty straightforward to multiply. So if we want to multiply these two square roots, we just multiply the numbers that are on the inside. Okay, so 3 and 18, that's going to be 54. Okay, but now I have to simplify that. Okay, so whenever we multiply, all our answers have to be in simplified terms. Okay, so now we have to simplify this. Okay, so I go back to that chart. What's the largest number that goes into 54 evenly? Which one? 25? I don't think 25 goes into 54 though. It's all right. 8? Okay. Remember, we're looking at those numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100.
9 does.
9 does. Okay. So 9 goes in there how many times? 6. It's good to know your multiplication table in this case. All right, so let's rewrite this now, simplified form. So what's going to go out in the front? 3, so 3 is going to go out in the front. Square root of 9 is 3, and 6 is going to be left underneath. Okay, we can't break the 6 down. Nothing goes into 6 that is of those numbers. All right, so that's it. So we multiply, and then we simplify. We'll put a variable inside here this time. Okay, so now we have a square root of 14x and a 7x squared. So I need to go 7 times 14 first of all. What does that equal to? 7 times 14, 98. So we have 98x. X and x squared is going to give us x cubed. Good. Okay, now we got to break it down. So see, now I have to find the largest perfect square that goes into 98 evenly. So I have to go back up to my chart and find that largest number. Anybody find it yet? 49 goes in there how many times? 2. Very good. So, let's work on this. So, what are we going to get of the numbers? What are we going to get on the outside? 7's going to go on the outside. Okay, good job. All right. I'm going to leave a little space there. What's going to go on the inside in the number case? 2. All right, so now, come on. Oh, here it comes. 2. Now I got to do the variable. Power is 3. It's a square root, so 2 goes into 3 once. With how much left over? 1. Okay, so that 2 goes into 3 once. That's why I have 1x there. 1 left over. That's why I have a leftover x in the radical. So we're going to multiply the numbers inside and then simplify. Let's see, I want to check to see. I didn't do it. Okay, we'll do a couple of these real quick too. Okay, they're also going to have you simplify some cube roots. So in this case, it's nice to have some cube roots written down, but not too many. Okay, so if we're going to simplify a cube root, here's how we do that. So now I have the cube root of 16, so I got to simplify that. So now I use my cube root chart to find the perfect cube that goes into 16. So what one of these numbers goes into 16 evenly? 8 does. 8 goes in there how many times? 2 times. All right. So now this is going to break down to cube root of 8 is 2, so I'm going to go 2 cube roots of this 2 left over. All right, so you're just going to have like a couple of those, 2 or 3, and that will be it. All right, most of the time we're going to spend time on square roots. All right. But you can kind of see simplifying is a little bit tricky. You got to know this. You just got to have this chart someplace written down. And you can only use those numbers, and finding the largest is the best. Any questions on simplifying or multiplying before you get a couple to work on? Yeah.
So we're trying to find the biggest number that can go in 2 times, basically, or as many times as possible.
It can go in as many times as possible. You got to find you want to find the largest, because that makes it the problem easier for you, right? So if we have like I think 128 might be a pretty good one. Because 2 goes in there 64 times, right? Okay. Well, 2 and 64 work. But you could also, somebody might say, well, doesn't 4 goes in there 32 times? Okay. I'm trying to write, stupid thing. Okay, but this 32, so this would be 2 square roots of 32. But see, the 32 can still be broken down. All right. So that's why you want to find the largest one that goes in there. That's why the 64 is the winner there. Okay. More good questions? I'll scratch that one out. Okay, so let's try a couple out here. Like we always do. And we'll go over them. Let's see, 485. I think that what I'm looking at has 3 on that page has 3,161. I think that's supposed to be 31 through 61. Odd. So. Let's talk about 75. Try those ones out, and then we'll go over them. I'll get out of the way so you can see them.